An electrical engineer has made a pair of components P and Q. The resistance of P decreases, so we have two resistance P and Q. The resistance of P decreases as the temperature rises. Temperature rises, the resistance of P decreases. The resistance of Q increases as the temperature rises. The total resistance of P and Q remains constant when the temperature changes. R here is constant. The two components are connected in series with a power source supplying constant current. Which statement is correct? If the temperature changes causes the potential difference P across to double, the potential across Q will always halve. This can be right. If the potential difference here is double, the potential difference here must be decreases, but it's not conditioned to always half. The difference, so we can consider this a correct answer. The difference between potential difference across P and the potential difference across Q not change with the temperature. V here constant and V here constant does not change with temperature. Of course not, because resistance changes here and changes here, so the potential difference also going to change with temperature. The potential difference across component P increases as the temperature rises. He said no, as resistance decreases, so the potential difference also decreases. So this one is wrong. The sum of potential difference of a P and the potential difference across Q does not change with the sum. Yes, the sum is constant because the resistance or the sum of resistance is always constant, so the sum of potential difference also constant. So this one is correct. Diagram shows a wire XY moving in a magnetic field. A current is induced in the wire. The current carrying wire XY experiences a force because of its interaction with the magnetic field. Which law gives the direction of the induced current and the direction of the force? Let's see first the direction of induced current. For induced current, we use Fleming right-hand rule. Using this rule, first finger direction of the magnetic field from north to south, second finger the direction of the electric current which we want, and the thumb direction of force which is upward. Shows the direction of the second finger from X to Y in this direction. About the force that acting on the wire will be, of course, in the opposite direction of its motion. Motion upwards, so it will be downward. Diagram 1 shows a magnet being pushed into a coil that is connected in center 0 sensitive voltmeter. As you see here, as the magnet approaching the coil, the voltmeter reflected toward this left, which means the current in this direction. Which row shows the direction of the pointer on the voltmeter when the magnet is as shown in the diagram 2 and 3? When the magnet is inside the coil, will induced current here and here should be opposite each other, will cancel each other out. So here we will have no current. In diagram 2, no current. In diagram 3, the magnet is moving away from the coil, so also induces a current but in the opposite direction. Here is to the left, so the current here should be to the right. So the answer is C. The purpose of the brushes and the split ring commutator in the DC motor. For this, the main function for them or main job for them is to keep the current in one direction. Keep the coil to change the size of the current, to keep the coil turning in the same direction, to keep the speed of rotation, to make output of a return coil. Keep the coil turning in the same direction. Diagram shows beta particles being directed between the poles of the magnet. Beta particle, in which direction will the particle will be deflected. Here, beta particle is negative, so we'll use filming right hand. First finger is the direction of magnetic field from north to south. So downward. Second finger's direction of the current or the particle. So the third finger, the thumb, is the direction of the force, will be out of page. And alpha particle and beta particle have the same kinetic energy. Why does alpha particle have a larger ionizing effect than beta particle as it passes through air? Both of them have the same kinetic energy but not the same velocity, because the mass of alpha particle is larger, so it has less velocity or less speed. The alpha particle has a larger charge. This is correct. Large charge, not a small charge. And larger velocity, not larger velocity, less smaller velocity. So it is closer to an air particle for a longer time. So the answer is B. A student is carrying out an experiment to measure the radiation from the radioactive source. He uses radiation detector and records the total count in 5 minutes interval. He does this 3 times with the source present and 3 times with the source absent. Here are the results. Total count in 5 minutes with source present and with the source absent. What is the average corrected count rate for the source? So we'll take here the average with the source 68 plus 73 plus 69 divided by 3. We found the average here is 70, and take the average of background radiation 25, 28, 22. We'll find the average here 25. So the corrected count rate is 70 minus 25 gives you 45 counts per 5 minutes. He needs for just minutes, so 45 divided by 5 gives you 9 count per minute. Question 38. The count rate measured near a radioactive source dropped from 542 counts per minute to 94 count per minute in 12 hours. The background remains constant at 30 counts per minute. What is the half-life of the source? Let's first the initial reading 542, and we will subtract the background radiation 30 equals 494. Then we take the final 94 minus 30 equals 64. Now we want to see 494. After one half-life, we divide it by 2, gives you 247. After another half-life, it is 1, 2, 3 divided by 2. After another half-life, it is 62, it's almost 64. So we are talking about 3 half-lives. 3 half-lives in 12 hours. So 12 divided by 3 gives you 4. So the half-life is 4 hours. Question 38. What happened when a protostar becomes a stable star? When it changes from protostar, when the protostar, the two forces acting on the protostar, inward force and outward force. Inward force because of the gravity and outward force because of radiation. When the two forces are equal, we reach a stable star. Okay, the inward force due gravity is balanced by the outward force to the higher temperature. This is correct. The table gives information about some of the planets in our solar system. We have the planets Earth, Jupiter, Mercury, and Uranus. Mass compared with the Earth. 1. This is the Earth. This is Jupiter, 320 times the Earth. Mercury is too small, 0.06 of the mass of the Earth. Uranus, 15. Average density 5.5, 1.3, 5.4, 1.3. Gravitational field strength as you see. As you see, the gravitational field strength here is proportional with the mass, not the average density. Which statement about these bands is correct. As the mass compared with the Earth increases, the average density increases. This is not actually correct because we have another factor which is the volume. See here the mass increases but the density decreases. When you compare Earth with Jupiter, the mass of Jupiter 320 times the Earth, but its average density is less. So there is another factor which is the volume. So this one is the average density increases. This is wrong. The mass compared with the Earth increases the gravitational field strength. This is correct. When the mass increases, the gravitational field strength also increases. As the average density increases, the gravitational no relationship between the density and the gravitational field strength. Average density is directly proportional to the gravitational field strength. Also, this is not correct. So mass is proportional with G. Which quantity is an estimate of the age of the universe? Of course, 1 over h. H naught here is Hubble constant.